This is section 8.8, arc length and circumference. Okay, so the first thing we're going to talk about is circumference. So circumference is, in comparison, kind of like the perimeter of a circle, so all the way around the outside of a circle. And we find that by using pi, okay? And then we've got the definition of pi on page 494. So what it says there is pi is equal to circumference divided by diameter. So C is the circumference and D is the diameter of a circle. That's going to be true for any circle. So anytime you have a circle and they give you the circumference or the distance around the outside, and then your diameter, which is all the way across the circle, if you divide those two values, you will always get pi, which is approximately equal to 3.14. So I'll kind of show you on my calculator here. The pi button on mine is above the division sign, so you have to go second and then pi. So the calculator approximates it out this far, 3.141592654. It keeps going on and on forever and never stops and never repeats itself. But in most applications, rounding is okay. But a lot of times we're also going to use exact answers, kind of like what we did with the square roots. So we'll just leave that pi symbol in there, and then that's just a commonly understood math symbol. Okay, next thing, circle circumference formula. So the circumference formula is going to be either circumference is equal to pi d. So circumference is equal to pi d. D stands for the diameter. Or also circumference is equal to 2 pi r, which that r in that case is the radius. So with a circle, diameter is all the way across, radius is halfway across. Okay, so depending on what they give you, you can either use diameter times pi, or you can take, if they give you the radius, and double that to get the diameter, and then take that times pi. Okay, so let's do some examples here. So on our example sheet, it says for a ceiling fan, the tip of the blade travels in a circle with a diameter of 46 inches. And then for a desk fan, the tip of the blade travels in a circle with a diameter of 6.5 inches. And we're supposed to find the circumference of each to the nearest hundredth of an inch. Okay, so we've got two circles. One of them has a diameter of 46 inches. And the other one has a diameter of 6.5 inches. Okay, so we want to find the circumference of both of those. So to find the circumference of this one, we would just take our diameter, which is 46, times pi. So if they wanted it in terms of exactness, or just an exact answer, it would be 46 pi. But since they want to the nearest hundredth of an inch, we'll do an approximation here. So just on your calculator, I typically use the pi button instead of 3.14. You can use 3.14, but it's not always the most accurate thing. There are other approximations too, so they do kind of show those up here. We're not going to do it. But 22 divided by 7 is also an approximation for pi, similar to 3.14. And also 355 divided by 113. So like if I did both of those on my calculator, 22 divided by 7 is pretty close to what pi is, and then also 355 divided by 113 is also pretty close to what pi is. That's actually really pretty close, but I usually don't remember those. I just use my pi button on my calculator, or 3.14 if I'm in a pinch without a pi button. But anything is fine as long as it's pretty close to this. So when I do this here, I do 46 and then second pi, which is approximately 144, and they want us to go to the hundredths, which is 2 positions behind the decimal, which would be 51 in this case, inches. And similar to perimeter, we don't have to do like inches squared or square inches. It's just inches in this case because it's just a distance, not an area or a coverage type thing. And then for our smaller one, for our circumference, it would be 6.5 pi, so our diameter 6.5 times pi. So if I did that on my calculator, 6.5 second pi, I'd get approximately equal to 20.5 0.42 inches for that circumference. Okay, so those are our approximates there. And then back to our note sheet, exact circumference. So exact is kind of what I was talking about before. So exact answers, what you do is you leave the pi in them. So just like exact answers with the square root, we leave it as, 2 times the square root of 2 instead of figuring out what it is as a decimal. So here, if we were doing our exact answers, we would be using those values, okay, instead of the approximations. So what we're going to do is we're going to actually use that for these next ones. So this is going off of that example we just did. So for the fans in example 1, suppose the tip of the ceiling fan, so our bigger one there, moves at a rate of 5 revolutions per minute. So a revolution is like 1 time around. So like to get from here all the way around back to there, that's 1 revolution. So it's doing 5 of those in 1 minute. Or not 1 minute, 1 second. And then the tip of the desk fan, so the smaller one there, moves at a rate of 150 revolutions per second. So from there all the way around, it's going to do that 150 times in a second. So that's going pretty quick. And we're supposed to figure out which travels further, the tip of the ceiling fan in 45 seconds or the tip of the desk fan in 10 seconds. Okay, and we're supposed to figure out by how much, rounded to the nearest inch. Okay, so what I'm going to do is I'm going to take my circumferences. So my first circumference there is 46 pi is what I'm going to use. Typically when you have to do a lot of math on something, it's easier to use your exact answers versus your rounded ones as the decimal, because your answer might not come out exactly how you want it to. So I always use my exacts when I can. Until the very end if they ask me to round, but I typically don't ever round until I get to the very end, because even the slightest of a decimal change with the rounding can throw off your answer. Okay, so I've got my circumference of the big fan there is 46 pi, and it's doing 5 revolutions per second. So it's going to go 5 times around per second, so I'm going to go times 5 revolutions, because that would give me my distance that it goes in a second. And then for my ceiling fan, I'm doing this for 45 seconds. So I'm also going to take that times 45 seconds. So if I multiply all that out, again, I'm going to leave that pi in there. So I'm just going to take 46 times 5 times 45. Oops. Sorry. 46 times 5 times 45, which is 10,350. And I put the pi with it, so that's how far it's going in 45 seconds. Now I want to do this for the desk fan, but I want to do it in 10 seconds. So my desk fan one is 6.5 pi, and that one is going 150 revolutions. So 150 revolutions, and we're only going 10 seconds for this one. Okay, so if I do that out, that would be 6.5 times 150 times 10, which would give me 9,750, and again, just stick the pi with it. Then what you can do, because it wants to figure out how much faster or how much farther this one is going to go than this one, what I could do to figure out how much further it is I could subtract those values. So I could do 10,350 pi minus, is that right, minus? No, not minus. What do I need to do here? Divide. Let me try this quick. So if I take 10,350 divide by, oh, I didn't need to subtract. Sorry. I was looking at my answer key, and the answer I had here didn't look very good. Shouldn't second guess myself, I guess. Okay, so subtract. Sorry about that. If I subtract those values, did it out here quick, you should get 600 pi. And then from there, what you're going to do is now you're going to do your approximation part. So now I would take 600 times pi on my calculator and do my approximation now. And the reason I wait till the end is you just get a lot nicer numbers. So 600 times second pi, or just 600 pi would work. and you get approximately 1,884.9, and then what do we want to go to? Nearest inch, so I guess we are going to a 5 there, so approximately 1,885. Okay, yeah, sorry about that delay there. I was looking at my note sheet and it did not make any sense, and then I'm like, I'm pretty sure it's subtract. So, lesson learned, don't second guess yourself, I guess. Alright, on to the next thing, I guess. So what do we do there? We just did that example 2. Now we're going to do stuff with arc length. Okay, so if you remember arcs are basically like part of a circle. So like if I had a circle here, center there, my arc is basically like your distance between a wedge. So an arc could be like from there to there. Okay, so how we figure out arc lengths is we take our degree measure of the arc, so whatever this degree amount is here, we take that and we divide it by 360 because the whole way around the circle is 360, and then we take that times our circumference. So basically, this is kind of like the fraction of the circle that we've got there, so whatever it is out of 360, which would be like the whole, and then you take that times your circumference, which would be your whole distance around, and then what that'll do is it'll give you the fraction of the circle that your arc actually is. So let's do some problems with that. Okay, what are we on? Example 3 here. So in circle T, T to P is 18 centimeters, so that looks like a radius. And then angle PTQ is 50, and we're supposed to find the exact length of the arc from P all the way around to Q. Okay, so let's use that formula we just had before. So degree measure of our arc divided by 360. Well, our arc here is 50 degrees, so we do 50 degrees divided by 360. And then you take that times your circumference. So we're going to actually have to figure out what our circumference is here then. So to find circumference is 2 pi r, and I'm using 2 pi r because we have a radius here. So 2 pi and our radius is 18. If they gave us a diameter, we would just take that times pi. So if I take 18 times 2, that would be 36. So our circumference is 36 pi. And I'm leaving it with the pi because they want exact answers for this. So now I'm going to sub in my circumference with that fraction there. So 50 divided by 360 times my circumference that I just found, 36 pi. So what I would do to keep this as like exact numbers here is I would treat this kind of like a fraction as well by putting it over 1. And then look to see if there's anything I could reduce, which here 36 and 360, I could pull a 36 out of each of those, so that would be 1. And this would drop to 10. And then from there, if I think, okay, well now I've got 1's there, so that's just pi. And here I've got 50 over 10. Well, 50 divided by the same 10 is the same as 5. So 5 pi would be my answer. And then my label would just be centimeters. So that's how you do it as an exact value. Now if they ask for an approximation, then at that point, then you just take 5 times your pi, or 3.14, then you get your approximation. Okay, last thing here, we've got our last example. So we've got a circle has a radius of 8 inches, so from middle out to the edge is 8. A wedge of that circle has an arc length of 8 inches, so the wedge here has an arc length of 8 inches as well, and we are supposed to find the angle right in here to the nearest 1/10 of degree. Okay, so what I would first think here is, okay, let's find our circumference of this whole circle. So with my whole circle, I've got a radius of 8, so to find the circumference of the whole thing, I would do 2 pi r, so 2 pi and then times my 8. So 2 times 8 would be 16 pi for my circumference of the whole thing. And then from there I'd think, okay, well, if I'm thinking about my degree of the arc over 360, that's kind of similar to part over the whole. Well, my part here of my circle would be the 8, and my whole circle, or the whole circumference, would be 16 pi. So it's basically like my part of the circle, or kind of like my fraction here, is 8 over the whole circle, which is the 16 pi, kind of similar to what we had here with this formula, but instead of degree over the total degree, I'm going to do my arc length over my total circumference in this case. Okay, so I want to figure out what that is. So to reduce this down here, I know 8 over 16 is the same as like 1/2. So I'm going to turn that into 1/2, and then the pi, make sure that that stays on the bottom. And then once I get that, that basically gives me what portion this 8 inches is. And then I want to take that times 360, because now I want to figure out the degree amount that that matches with. So now I'm going to take my 1/2 pi, or my 1/2, sorry, the pi's on the bottom, 1 over 2 pi is what I should actually say, times 360, which would be all the way around the circle. So I would just do this on my calculator then, because now they want an approximation. So if they didn't want an approximation, you could just leave it as that, but since they do want an approximation, let's do 1 divided by 2, actually I'm going to put this in parentheses, 1 divided by 2 pi, get that answer, and then I'm going to directly take that answer with my answer button and go second answer. So that's just going to take exactly what it says there, and now I'm going to take that times 360, and I should get approximately 57 point, what are we supposed to round here to? Nearest 10th, so that would be 1 position behind the decimal point, so 57.3 degrees. Okay? Okay, so that is it for notes for this section. So you got page 497, 1 to 8 all, and 10 to 16 even for the assignment.